Imagine a world where the Earth never rises. A world where the sky is always black, even when the sun is shining. And the silence is so absolute, it weighs on the psyche heavier than the G-forces of a rocket launch. This isn't science fiction. This place is located just 240,000 miles away from us, the far side of the Moon, a territory that for centuries has been synonymous with mystery for humanity. We've seen the far side of Mars. We've photographed the icy canyons of Pluto. We've even peered beyond the event horizon of a black hole. But our own satellite, its hidden half, remained a blank spot on the map for us. A territory where robots and humans were afraid to tread. Why did this happen? It wasn't because we lacked rocket power. It was a matter of physics and fear. The Moon is tidally locked with the Earth. It's a gravitational dance in which the satellite is always turned toward its partner with the same face. To an observer on Earth, the far side simply doesn't exist. And this creates the main problem for any engineer: a total lack of communication. Radio waves travel in straight lines. They cannot bend around the solid rock mass of the Moon. Any device that risks going behind the lunar horizon would instantly go deaf and blind. It would remain alone with the cosmos, with no way to call for help, no way to transmit what it sees. That is exactly why all the American Apollo missions, all the Soviet Lunas and rovers landed only on the visible side. It was safe there. There, the Earth always hung overhead like a giant radio tower. But in 2019, China decided to break this unspoken taboo. The Chang'e 4 mission wasn't just another flight to the Moon. It was a challenge to the entire history of astronautics. They decided to send a lander and a rover to a place where no one had ever made a soft landing. Into the von Karman crater, located inside the giant South Pole-Aitken basin. And what they discovered there overturned our understanding of how not only the Moon, but our own Earth was formed. This isn't a story about flags and footprints in the dust. This is a geological thriller. We're going to talk about how the Chinese rover U-22, a small robot weighing 300 pounds, stumbled upon traces of a planetary-scale catastrophe. About how it found strange glass that was initially mistaken for alien slime. About how scientists, for the first time in history, were able to touch the Moon's mantle, its innards, which should be hidden under tens of miles of crust. And about why the far side of the Moon might become the key to infinite energy for humanity. Get comfortable, because we are embarking on a journey to the dark side, and what we see there is definitely not something they showed you in astronomy class. Before we touch the surface, we need to understand how China managed to do this at all. How can you control a robot that can't hear you? The answer lies in a beautiful ancient legend and complex celestial mechanics. The Chinese named their plan Kueqiao, which translates as Magpie Bridge. In mythology, magpies flock together to create a bridge across the Milky Way so that separated lovers can meet. In reality, the role of the magpies was played by a special relay satellite. 6 months before the launch of the main mission, China launched this satellite to the Lagrange point L2 of the Earth-Moon system. This is a unique spot in space, a gravitational pocket located about 40,000 miles behind the Moon. If you place a satellite there, it will hang there as if tethered by an invisible string. From this position, it has a fantastic view. It sees the far side of the Moon in the palm of its hand, and at the same time, it sees Earth peeking out from behind the edge of the Moon. This satellite became the very mirror through which operators from Beijing could send commands into the blind zone. Without this elegant solution, the mission would have ended in failure before it even began. And so, on January 3, 2019, the Chang'e 4 lander began its descent. These were minutes that stretched into eternity. On Earth, No one could intervene in the process. The signal went through the relay with a delay, and if something had gone wrong, operators would have learned about the crash only after the device had already turned into a pile of scrap metal. The module's computer worked autonomously. It scanned the surface with lasers, built a 3D map of the terrain in real time, and looked for a flat spot among the craters and boulders. The engine slowed the fall, kicking up clouds of gray dust that didn't settle as quickly as on Earth due to the weak gravity. Touchdown, silence. The solar panels unfolded. The antenna turned toward the relay satellite. Link established. For the first time in history, humanity received a panoramic shot from the surface of the far side of the moon. And this shot was different from anything we had seen before. The landing site was not chosen by chance. The von Karman crater isn't just a hole in the ground. It is located inside the South Pole-Aitken basin. Remember that name because it is possibly the most important geological structure in the entire solar system. It is a giant dent that stretches from the moon's south pole almost to the equator on the far side. The diameter of this funnel is 1,500 miles. The depth up to 8 miles. To help you realize the scale, if this crater were on Earth, it would cover the territory from New York to Dallas, and its bottom would be deeper than the Mariana Trench. This is the scar from a blow of monstrous force that happened about 4 billion years ago. Some wandering planetoid slammed into the young moon and nearly split it in half. The impact was so powerful that it punched right through the lunar crust. Why is this so important to us? Imagine you want to know what the Earth is made of inside. We can't drill a hole to the center of the planet. The deepest hole humanity has ever dug, the Kola Super Deep Borehole, went down only 7.5 miles. That's not even a scratch on the skin of an apple, if you compare the Earth to a fruit. We have never seen Earth's mantle in its pure form. But on the moon, nature did the work for us. That ancient asteroid acted like a giant excavator. It turned the satellite's insides out, throwing mantle material onto the surface. This is exactly the material the Yutu-2 rover was hunting for. If we study the moon's mantle, we will understand how the Earth was formed, because according to the most popular theory, the moon is flesh of the Earth's flesh, torn from it during an even earlier collision. We effectively flew there to dig into our own, very distant past. 12 hours after landing, the rover rolled out onto the surface. Yutu-2, or Jade Rabbit 2. It's a small 6-wheeled geologist. It moved very cautiously. Control happened with huge pauses. The operator sent a command to drive 3 feet forward. The signal flew to the satellite behind the moon. From there, down to the rover. The rover executed the command, took a picture of the result, and sent the report back. This isn't a race in a video game. It's a chess match with eternity. The first thing that caught the camera's eye was the color of the soil. On the visible side of the moon, where the Americans walked, the soil is dark, basaltic, because it consists of solidified lava from ancient volcanoes. Here, at the bottom of the Aitken Basin, everything was different. The regolith was lighter, and its composition, as the very first spectrometer tests showed, was completely different. The moon is a cruel place. There is no atmosphere to protect the surface from micrometeorites. For billions of years, tiny grains of sand at huge speeds have bombarded the rocks, grinding them into the finest powder, similar to flour. This dust, regolith, is very dangerous. It is sharp, like broken glass, because there is no wind or water to smooth the edges of the grains. It sticks to everything, clogs mechanisms, and scratches camera lenses. Engineers had to create special wheels made of metal mesh, so the rover wouldn't get bogged down in this quicksand-like dust. U-22 moved from one stone block to another, scanning them with its infrared spectrometer. This instrument allows it to see the chemical composition of a rock without destroying it. It looks at how the stone reflects light and determines which minerals are in it by the spectrum. And so, a few lunar days later, and one day on the Moon lasts 2 Earth weeks, the rover stumbled upon its first major find. The spectrometer data showed the presence of 2 key minerals, olivine and low-calcium pyroxene. To the average person, these are just names of rocks. But for the geologists at Mission Control, this was a moment of triumph comparable to discovering a gold vein. Olivine is the main marker of the mantle. It is a heavy greenish mineral that sinks in molten magma. When a planet or moon is in a molten state, heavy olivine sinks down toward the core, while light minerals float up, forming the crust. Finding olivine on the surface is nonsense. It shouldn't be there. It's like finding a peach pit lying separate from the fruit. The presence of olivine and pyroxene confirmed the theory. We really are at the site of a grand lunar gutting. The asteroid impact stripped off the crust and exposed the mantle. This discovery put an end to a long dispute among scientists. Before the Chang'e 4 mission, there were doubts. What if the Aitken basin isn't that deep? What if it's just mixed-up crust? Now we know for sure. The insides of the Moon are accessible for study. This opens up fantastic prospects. We don't need to drill wells hundreds of miles deep. Mantle samples are lying right under our feet, dusted with powder. Just pick them up and study them. But that was only the beginning. The rover continued its journey, going deeper into the crater. And the further it drove, the stranger the finds became. In one of the small craters, just a few feet in diameter, the cameras recorded something that caused a real stir on the internet and confusion among scientists. Amidst the gray, matte, monotonous desert, something was glistening. It was a material that clearly differed from the surrounding regolith. It had a strange color, described in the initial reports as greenish and dark, and, most surprisingly, it looked moist or gel-like. The news that China found gel on the Moon instantly flew across the headlines of the tabloids. People began to build theories. Are these traces of life? Is it the slime of an alien organism? Is it discarded waste from a secret base? Of course, the imagination painted the most incredible pictures. Reality turned out to be more prosaic, but from a scientific point of view, much more interesting. U-22 operators exercised extreme caution. They didn't immediately poke the unknown substance with the manipulator. First, they zoomed in with the cameras and took a series of high-resolution shots under different lighting. Then, they used the spectrometer. The analysis showed that it was glass. But where does glass come from on the Moon? These aren't shards of a bottle left by tourists. This is impactite. When a meteorite slams into lunar soil at a speed of 12 miles per second, kinetic energy instantly turns into thermal energy. The temperature at the epicenter of the explosion jumps to thousands of degrees. The rock doesn't just melt, it boils. The soil turns into liquid lava, which sprays in all directions and immediately, in the vacuum and cold of space, freezes. The result is natural glass, often dark in color, with bizarre shapes. Astronauts on the Apollo missions also found such glass. The famous orange soil found by Harrison Schmitt also consisted of tiny glass beads of volcanic origin. But the U-22 find was different. It was a sintered conglomerate, a shiny chunk looking like melted plastic. The fact that it looked gel-like was an optical illusion caused by the play of light and shadow on the smooth surface of the glass amidst the rough dust. But why is this glass so important? Because glass is a time capsule. At the moment of melting, It captures the composition of the environment inside itself. It preserves gases, isotopes, and minerals. By studying this glass, we can find out exactly which meteorite hit this place and what composition the soil had at that second. It's like finding a bullet at a crime scene. Beyond geology, the Chang'e 4 mission brought us precise data on the climate of the far side. And this data forced engineers to reconsider plans for future bases. We knew the moon has no atmosphere to hold heat, but reality turned out to be harsher than the calculations. The lander's sensors recorded that during the lunar night, the temperature drops to minus 310 degrees Fahrenheit. This is colder than expected. On the visible side, night temperatures usually hold around minus 270. A difference of 40 degrees might seem insignificant to us sitting in warm rooms, but for electronics, it is a death sentence. Batteries freeze, metal becomes brittle, microchips fail. To survive this night, which lasts 2 weeks, Chinese engineers used radioisotope heat sources. Little nuclear stoves running on decaying plutonium warmed the rover's insides while cosmic cold reigned outside. And when the day came, another hell began. The sun at its zenith heated the surface to plus 250 degrees Fahrenheit. U-22 was forced to take a siesta, shutting down at noon so as not to overheat. This extreme temperature swing tells us about the properties of the soil on the far side. It works as a perfect thermal insulator, not letting heat deep down and instantly cooling off without the sun. This knowledge is critically important. If we are going to build bases there, we will have to dig deep underground, because on the surface, conditions are incompatible with both technology and life. We have covered only a third of our journey. We've learned how China landed on the far side and what they found in the first months. But the most important discoveries related to water, the origin of the moon, and the new samples brought by the next mission, Chang'e 6, await us ahead. We will learn why the far side has a thicker crust and discuss a theory that gives you goosebumps. The theory that Earth once had 2 moons, and one of them died to create the landscape that a lonely Chinese robot is studying right now. Let's step away from the robots for a moment and look at the moon globally. If you take a map of the hemispheres, you will see a striking thing. The visible side, the one that shines on us at night, is covered with dark spots. These are lunar maria, or seas, huge plains of solidified basaltic lava. Ancient astronomers thought there was water there, which is why they called them seas. In reality, these are traces of giant eruptions when liquid magma broke through the crust and flooded the lowlands. But look at the map of the far side, compiled by satellites and confirmed by Chang'e 4. There are practically no seas there. Only a couple of % of the surface is covered with lava, while on the visible side, it's almost a third. Instead of seas, there is a solid mess of craters and mountains. This is called the lunar dichotomy, and it is the biggest mystery of selenology in the last half-century. Why did nature create such a lopsided world? Why is the crust on the visible side thin, while on the far side it is thick, like armor? Data obtained by the Chinese mission pours fuel on the fire of one incredible theory: the Big Splat theory. Scientists suggest that 4.5 billion years ago, after that very impact of Theia with Earth, not one moon formed in orbit, but 2. One big one, our moon, and a second smaller one, about a third the size of the first. They hung in the sky like 2 sisters, rotating in resonance. But gravitational idyll could not last forever. Tens of millions of years later, the smaller sister's orbit became unstable. It began to approach the big moon, and eventually, they collided. But this wasn't a head-on attack at cosmic speeds that would have blown both bodies to dust. No, the relative speed was low. The smaller moon slowly caught up with the big one and literally splattered across its far side. Imagine throwing a piece of clay against a wall. It doesn't bounce off, it sticks and smears. This is exactly what might have happened. The far side of the moon is the remains of Earth's second, dead moon. It plastered itself on top, creating an extra thick layer of crust. That is why magma from the depths found it so difficult to break through to the outside on this side. The armor was too thick. The Yutu-2 rover is currently effectively driving on the grave of Earth's second moon. The rover's ground-penetrating radars, which can see through the soil to a depth of 1,000 feet, confirm a layered, mixed structure that fits perfectly into this dramatic picture. But if you think a second moon is the weirdest thing there, hold on tight. Gravity maps, refined thanks to data from the Chang'e orbital modules, revealed something frightening under the South Pole-Aitken basin. There, deep beneath the surface, lies a huge mass, a density anomaly. Scientists call this a mascon, short for mass concentration. Something very heavy and dense pulls satellites down when they fly over this area. Calculations show that the mass of this object is in the quintillions of tons. That's a number with 18 zeros. In size, this hidden structure is 5 times larger than the big island of Hawaii. Where did it come from? The main version sounds like the plot of a sci-fi movie. It is the metal core of that very asteroid killer that created the Aitken Basin. 4 billion years ago, a giant space wanderer slammed into the moon. Upon impact, its rocky shell vaporized, but the heavy iron-nickel core punched through the crust and got stuck in the moon's upper mantle. It didn't melt completely, didn't dissolve, but remained hanging there, like a bullet in the body of a wounded soldier. Imagine this scale. Beneath the wheels of a small Chinese rover, under miles of dust and stone, lies a dead metallic leviathan, an intruder from the depths of space, which forever became part of the moon. It is precisely this object that creates the gravitational anomaly, and its presence could have influenced the magnetic fields of the ancient moon, traces of which we also find in samples. While Yutu-2 was digging into the geological past, the Chang'e 4 lander was engaged in the astrophysics of the future. We already mentioned that the far side is isolated from Earth's radio noise. For a layman, this is a communication problem. For an astronomer, it is manna from heaven. Earth glows in the radio range like a Christmas tree. Our radars, phones, and GPS satellites create so much noise that hearing weak signals from deep space is almost impossible. We are particularly interested in low frequencies. It is at these frequencies that the era of the birth of the first stars sounds, the so-called dark ages of the universe and the epoch of ionization. This is the period immediately after the Big Bang, when the first stars had not yet ignited in the universe, and there was only cold hydrogen. You cannot hear the whisper of this hydrogen from Earth. Our planet's ionosphere blocks these waves, and what gets through drowns in the noise of human civilization. But the moon is the perfect shield. During the lunar night, when the sun, which also makes noise in the radio range, hides behind the horizon and Earth is on the other side, absolute radio silence descends on the far side of the moon. The Chinese module deployed its antennas to listen to this ancient ether. These are just the first steps, experiments to test the technology. But they proved, if we want to know how the universe was born, we need to build radio telescopes right there. And in the plans of China and international consortiums, there are already projects to deploy giant networks of antennas on the far side. It will be the most sensitive ear of humanity, pressed against the door at the moment of the world's creation. The Chang'e 4 mission was a one-way ticket. The rover and the lander will remain in the von Karman crater forever, as monuments to human curiosity. But that wasn't enough for the scientists. Spectrometers are good, but nothing replaces a full-scale laboratory on Earth. They needed soil. They needed to bring a piece of the far side home. Thus, the Chang'e 6 mission was born. If Chang'e 4 was difficult, Chang'e 6 was extraordinarily complex. The launch took place on May 3, 2024. The flight scheme resembled a ballet involving 4 different spacecraft: an orbiter, a lander, an ascender, and a return capsule. On June 2, 2024, the lander touched down in the Apollo basin. This is another large impact structure inside that same giant Aitken basin. The choice of location was surgical. Scientists wanted to hit a spot where the crust is thinnest, where the chances of scooping up mantle material are maximal. The robot had only 2 days to work. It was a race against time. The drill bit into the surface, taking samples from depth, while a mechanical arm scooped up rocks from the surface. All this happened in automatic mode under the supervision of artificial intelligence, because waiting for commands from Earth via the relay satellite was taking too long for such precise operations. But the scariest part was ahead: takeoff. Taking off from the Moon is not easy in general, but taking off from the far side without seeing Earth is a technical feat. On June 4th, the ascent module with the precious cargo tore away from the surface. Cameras captured the lander remaining on the gray dust, with an unfurled flag made of basalt fiber, a material that does not fade or degrade from radiation and temperature changes. Then began the magic of celestial mechanics. The ascent module had to find the service module waiting for it in orbit and dock with it. Automatic docking in lunar orbit. This is a level of complexity available to only a few nations. They did it. The container with the soil was transferred, and the capsule rushed toward Earth. On June 25, 2024, it landed in Inner Mongolia, delivering to us 4.3 pounds of material from another world, almost 4.5 pounds of dust and rocks. It seems like a little, but for science, it is priceless. The very first opening of the container in Beijing showed, this soil is different from anything we have seen. It is lighter in color, its density is different, but the main thing is hidden in the chemistry. We used to think the Moon died a long time ago, that volcanoes there went extinct 3 or even 3.5 billion years ago. Samples brought by American Apollos and Soviet Lunas from the visible side confirmed this. They were all very old. This created a picture of a geologically dead body. But preliminary analysis of Chinese samples from the Chang'e 5 mission, which landed on the visible side but in a geologically young region, and initial data on Chang'e 6 are breaking this paradigm. It turns out the Moon was alive for much longer. We are finding basalts that are only 2 billion years old. For geology, that is yesterday. This means the Moon's heart beat for 1 billion years longer than theories predicted. How is this possible? A small body should cool down quickly. What heated the Moon from the inside? Radioactive decay? Tidal friction from Earth's gravity? The answer lies in these new 2 kilograms of soil. Scientists are looking for so-called creep rocks in them. This is an acronym for chemical elements: potassium, rare earth elements, and phosphorus. These elements work as heat carriers. They could have kept the mantle in a molten state for a long time. If we prove that volcanism on the far side was active just 2 billion years ago, we will have to rewrite the history of the entire solar system. It also means that the Moon's depths might still be warmer than we think. And where there is heat, there is energy. And, of course, water. The most important word in any space program. Without water, colonization is impossible. Bringing water from Earth is insanely expensive. 1 liter of water on the Moon costs as much as a gold bar due to shipping costs. That is why we are looking for water there. We already know that at the bottom of polar craters, where the sun never shines, lie deposits of water ice. This is a strategic reserve. But climbing into eternal darkness at temperatures of -400 degrees Fahrenheit is an arch-difficult task. It is much more interesting to find water right in the soil, under the sun. Spectrometers on Chang'e 5 and Chang'e 6 made a breakthrough. They found water not in the form of ice, but in the form of hydroxyl groups locked inside the crystal lattice of minerals, for example, in apatite. This is so-called endogenous water, water that was born with the Moon and not brought by comets. What does this mean for us? It means lunar soil isn't dry sand. It is a sponge that soaked up water billions of years ago. If you heat this soil, the water is released. According to calculations based on Chinese data, from 1 ton of lunar regolith, you can extract about 4 to 6 ounces of water. It seems like a drop in the bucket? But on an industrial scale, when excavators are processing thousands of tons, these are rivers of water. Water that can be drunk, used to water plants in greenhouses, and, most importantly, split into oxygen for breathing and hydrogen for rocket fuel. The far side of the Moon stops being just an object of research. It turns into a resource base, and China understands this perfectly. Their program isn't limited to scientific curiosity. It is a planned reconnaissance of territory before expansion. Let's return to that glass found by U22. We talked about it as a geological find, but it has another application: materials science. Glass formed in a vacuum and weak gravity possesses unique properties. It is stronger, has different transparency, and different resistance to radiation. Chinese scientists are seriously considering the possibility of producing glass and ceramics right on the Moon. Why bring construction materials from Earth if you can melt regolith with lasers or solar concentrators and print houses, roads, and landing pads? Experiments on 3D printing with lunar soil are already being conducted on Earth, simulating conditions. Samples brought by Chang'e 6 will allow these printers to be calibrated with perfect precision. We stand on the threshold of the era of lunar architecture, and the first buildings on the Moon will likely be gray, the color of remelted dust from the far side. But lunar resources are not just water and building materials, it is also energy. The holy grail of energy is helium-3. This is an isotope that is ideal for thermonuclear fusion. It is not radioactive, the reaction with it is clean and incredibly powerful. On Earth, it is almost non-existent. Our magnetic field and atmosphere block it. But the Moon, devoid of armor, has been soaking up helium-3 from the solar wind for billions of years. There is a hypothesis that the concentration of helium-3 on the far side might be higher, or its extraction might be easier due to the characteristics of the regolith, which is not as heavily mixed by lava flows there. If this is confirmed, the far side of the Moon will become the Persian Gulf of the 22nd century. Whoever controls the extraction of helium-3 will control the energy market of Earth. The political aspect of these discoveries cannot be ignored. The Outer Space Treaty of '67 says that celestial bodies cannot belong to any country. But it says nothing about the resources you have extracted. This is a gray zone, and China, by being the first to plant a flag and begin active reconnaissance on the far side, has effectively staked a claim to first dibs. In the next, final part of our story, we will talk about biological experiments, about how the Chinese managed to grow the first plant on the Moon, and why fruit flies are our main test pilots. We will discuss plans for the construction of the International Lunar Research Station and how this outpost will become a springboard for the jump to Mars. We will also touch on a philosophical question. Are we, as a species, ready to transfer our conflicts and ambitions to another celestial body? The history of the far side of the moon is just beginning, and you and I are witnesses to the first lines of this new chapter. Let's forget about radiation, vacuum, and dead rock for a moment. Imagine something completely alien to this world: a tender, green sprout. On January 3rd, 2019, immediately after the landing of Chang'e 4, one of the most amazing chapters in the history of biology began. On board the lander was a small aluminum cylinder weighing just nearly 7 pounds. Inside this sealed container, Chinese scientists created a microcosm, a small model of Earth. There were seeds of cotton, rapeseed, potato, and thale cress, as well as fruit fly eggs and yeast. The idea was beautiful and bold: to create a closed ecosystem where plants produce oxygen, flies breathe it, and produce carbon dioxide, which the plants consume again. This was the first biological experiment in the history of humanity on the surface of another celestial body. Americans grew plants in orbit, on Skylab and the ISS, but no one had ever tried to do it on the moon, under conditions of real lunar gravity, which is 6 times weaker than Earth's, and under the protection of only the thin wall of a container against cosmic radiation. And a miracle happened. Cameras inside the cylinder transmitted a photo to Earth that went into textbooks. A cotton seed had sprouted. Amidst the dead, gray, eternal desert appeared a tiny green flag of life. It unfolded 2 leaves. It was a symbol of incredible resilience. Life, born on Earth, for the first time attempted to establish a foothold on another world. Unfortunately, this triumph was short-lived. The experiment was designed for a short time. When the lunar night fell, the temperature outside dropped to -310 degrees Fahrenheit. The container didn't have its own powerful heater to survive 2 weeks of such hell. The biosphere froze. Life died. But this brief moment proved the main thing. Lunar gravity is not an obstacle for plant growth. They sense which way is up and which is down, even at 1/6 G. As for the animals, things turned out to be more complicated. There is no data on whether the fruit flies hatched. Most likely not. But the very fact that we started carrying our genetic code there suggests that we have ceased to be mere observers. We have become sowers. Potato and cotton were not chosen by chance. Cotton is clothing, potato is food. This is the basic colonist starter pack. China effectively tested the farm of the future. But if we want to grow potatoes there and live there ourselves, we need to deal with the main killer: radiation. Before the Chang'e 4 mission, we only had calculated models. We knew the moon has no atmosphere or magnetic field, so cosmic rays hit the surface point blank. But we didn't have precise measurements right on the surface, long-term and detailed. On board, the Chinese lander was a German-made instrument, the Lunar Neutron and Dosimetry Telescope. It worked continuously, measuring the level of radiation that an astronaut standing on the surface in a spacesuit would receive. The numbers we got are sobering. The radiation level on the moon is about 200 times higher than on Earth, and 2 to 3 times higher than on board the International Space Station. The ISS flies low. It is still protected by Earth's magnetic field. The moon, however, is open to all the winds of the galaxy. This means that living on the surface in beautiful glass domes, as depicted in sci-fi, is impossible. It is deadly dangerous. Galactic cosmic rays are heavy charged particles accelerated by supernova explosions to near-light speeds. They pierce ship hulls and human bodies right through, destroying DNA like microscopic bullets. Data from Chang'e 4 settled the argument about the design of future bases. The only way to survive on the moon for a long time is to bury ourselves in the ground. we need to go underground. And here, geological discoveries take the stage again. Chinese scientists are actively studying lava tubes. These are giant tunnels left over from ancient eruptions. When a river of lava flowed, the top layer cooled and hardened, forming a roof, while the liquid lava inside flowed out, leaving an empty pipe. On Earth, such caves have a diameter of a few yards. On the Moon, due to low gravity, they can be miles wide. These are ready-made cities, with a roof hundreds of feet thick made of basalt, which perfectly protects against radiation, meteorites, and temperature changes. Inside such a tube, the temperature is constant, about -4 degrees Fahrenheit. That is a resort compared to the surface. China is already developing spelunker robots that will have to descend into these dark chasms and map the underground. Perhaps it is there, in the darkness of lunar caves, that humanity's first real home off Earth will be built. All these discoveries, water, helium-3, caves, plant resilience, are not just science for the sake of science. They are bricks in the foundation of a concrete plan. This plan has a name: the International Lunar Research Station, or ILRS. This is a joint mega-project between China and Russia, which other countries are gradually joining. And it is not just a repeat of the Apollo program. Apollo was flag planting, flew in, took rocks, flew away. The ILRS is about permanent presence. The plan is laid out by year. By 2030, China plans to land its taikonauts on the Moon. But not on the far side, but first on the South Pole, where conditions are slightly easier, but there is also water. However, the far side remains a strategic reserve for science and resource extraction. By the mid-30s, base construction will begin, and construction methods will be revolutionary. No one is bringing concrete from Earth. It is insanely expensive. Robots will do the building. Imagine a swarm of autonomous spiders equipped with 3D printers. They will collect lunar dust, mix it with a special binding agent, which can also be extracted on site, and layer by layer print walls, hangars, and roads. Technology for sintering lunar regolith with microwaves or lasers is already being tested. The resulting material is not inferior to concrete in strength. Chinese engineers have even come up with a design for buildings in the shape of an eggshell, which distributes the load perfectly. This base will be modular. First, the energy block, nuclear reactor and solar fields. Then, the communications center. Then, laboratories and living modules. At first, only robots will live there, but by 2040, the station is supposed to become inhabited, and the far side of the Moon will play a key role in this. That is where they plan to place the giant radio telescope we talked about. Antennas will be unrolled right across the surface of craters, turning natural bowls into ears listening to the universe. It will be the most sensitive instrument in the history of astronomy. We cannot ignore the elephant in the room: geopolitics. China's discoveries on the far side of the Moon have caused not only admiration from scientists, but also serious concern in the offices of generals and politicians of other countries. Space has once again become an arena of rivalry. On one side, the Artemis program led by the USA, Europe, and Japan. On the other, China and its partners. Both are aiming for the same places: the water-rich South Pole and strategically important points. Why is this important? Because there aren't that many convenient places for landing and construction on the Moon. Peaks of eternal light, mountain peaks at the poles where the sun shines almost constantly, giving free energy, are the most valuable pieces of real estate in the solar system. You can count them on one hand. Whoever occupies them first gets control over the region. China, having successfully mastered the far side, showed that it is capable of working where others cannot. Signal relay technologies, perfected on the Queqiao satellite, give China an advantage. They have already created their own navigation and communication infrastructure around the moon. While others are only planning, China already has a working network. This competition spurs progress. If there were no competition, we might have sat in low Earth orbit for another 50 years. Now, the race for lunar resources, for water and helium-3, is forcing humanity to move faster. And it doesn't matter whose flag stands first at the rim of the Shackleton crater. What matters is that humanity is leaving the cradle. But let's be honest, the moon is not the final goal. The moon is a sandbox. It is a proving ground. The main prize in this game is Mars. Everything China is doing right now on the far side of the moon is a dress rehearsal for a flight to the Red Planet. Why? Because Mars is far away. The signal there takes from 4 to 20 minutes. Controlling a landing in real time is impossible. The landing of Chang'e 4 and Chang'e 6 in automatic mode, using artificial intelligence to select the touchdown spot, is exactly the technology needed for Mars. China has already proven this by successfully landing the Zhurong rover in 2021 on the first try. Life support systems, radiation protection, growing plants, extracting water from soil, all this is first tested on the moon, 3 days' journey from home. If something breaks on the moon, there is a chance for rescue. If something breaks on Mars, you are dead. Therefore, a base on the moon built from local resources is a prototype of a Martian colony. Chinese engineers openly say, "We are learning to live on another celestial body." The moon is harsh. It is even harsher than Mars in many aspects: vacuum, temperature swings. So if we learn to survive here, Mars will seem like a resort to us. Furthermore, the moon is an ideal spaceport. Gravity there is weak. Taking off from the moon is easy. Imagine factories in lunar orbit building giant ships out of lunar aluminum and titanium, fueling them with lunar hydrogen and oxygen, and sending them to Mars, Jupiter, Saturn. We won't need to drag all this from Earth, overcoming its monstrous gravity. The moon will become our shipyard and our gas station. We are reaching the end of our journey. We started with the mystery of the dark side, descended into an ancient crater, found mantle, glass, water, and even saw cotton sprout. But there is one more aspect that scientists rarely talk about, but which is perhaps most important of all: philosophy. Apollo astronauts spoke of the overview effect. When you see the Earth whole, a small blue marble in the black void, your ideas about borders, wars, and conflicts are erased. You realize that we are all the crew of one ship. But the view from the far side of the moon is different. You can't see Earth there, at all. If you stand in the von Karman crater, you will be completely alone. Above you will be only infinite space. To see home, you would need to rise into orbit or move to the visible side. This feeling of absolute loneliness and detachment is a new psychological barrier that humanity has to overcome. Chinese missions have shown us that the moon is not just a nightlight. It is a complex, living, in a geological sense, rich world. A world that holds the history of our birth and the keys to our future survival. We found answers there to questions that plagued us for centuries. And we found new questions that will plague us for the coming centuries. What hides in the deep lava tubes? Are there, in the eternal darkness, reserves of ancient ice preserving traces of prebiotic chemistry? How will the human body behave if it lives in lunar gravity for a year? Will we be able to start a thermonuclear reaction on Earth using lunar helium-3 and give up oil and gas forever? We live in an amazing time. Right now, while we sleep, eat, go to work, there, on the far side of the moon, in the cold silence, stand human machines. They are listening to the stars. They are tasting the soil. They are waiting for our return. The Chang'e mission opened a door that was locked for billions of years. And now that we know what is across the threshold, there is no turning back. The far side of the moon has ceased to be a secret. It has become a goal. Thank you for spending this half hour with me on this journey. Space is closer than it seems. You just have to look up. And if you liked this video, if you felt this scale, subscribe to the channel. Next time, we will talk about why some scientists believe we are looking for life on Mars the wrong way, and what traces we might have missed right under our noses. See you in the future.